All right, so this video is going to help you with two questions that are similar to the homework assignment. This one here that we're looking at is going to be similar to page 165, number 1. So if you tried that problem, number 5. If you tried that problem and were having trouble, this will help you with that. Okay, so that's similar to that. So if you want to copy down the problem and try it, or you can just watch. So I'm going to do the substitution method for this problem, mainly because I see this 1z right there, and so I know I can solve for z easily. So I'm going to take this first equation, and I'm going to solve it for z. My recommendation is make your z with a line through it, because otherwise it might turn into a 2. You definitely don't want that. So negative 4x minus 2y minus 15. So this becomes the expression that I'm going to substitute into each of the other two equations. So I'm going to substitute it into z right here. So I'm recopying carefully. In place of the z, I'm putting parentheses. Copying carefully. Equals 45, right? So from here I would distribute and clean this up. And then when I go to combine like terms, the x's cancel, the y's cancel, and I'm left with negative 45 equals 45. So when you see this, you're going to say no solution. Because what this means is that line number 1 and line number 2 do not intersect with each other. So if 2 of the lines don't intersect, then it's not possible for all 3 of the lines to intersect. Now, I do want to keep going forward with this problem, though, because I want to show you something else that could happen. So imagine that this equation instead came out to be negative 16x minus 9y equals 10. Okay, this is just pretending. I'm going to write pretend. We're just pretending that happened. Okay, so now we're going to continue with the problem, and we're going to put z into the third equation we haven't used yet. So I'm replacing, copying carefully, equals negative 29. I'm going to distribute. And then combine like terms. Right? So now you've got these, if we call this equation 1, 2, and 3, we've now got this equation 4 and this equation 5. If you look at these two equations, notice that the left-hand side is identical on both of them. The only difference is this constant on the other side. So from our work in two variable systems, we should know that if the x and y part of the equation is exactly the same, but the constant part is different, that this is a no solution problem. Right? If those parts had been the same, so 76 and 76, then you can say it is all points on the line example. All right, so I just wanted to point that out to you in case that happens. It'll just save you a bit of work. If you go and continue to solve these equations, you will get to the same conclusion. However, you're just wasting some valuable time. So just look for these observations. All right, so here's another example. And this is going to be similar to page 165, number 1. Okay, so what's different about this system is that the third equation only has 2 variables, and so that jumps out and grabs my attention. This is great because this can be, like if we call this equation 1, 2, and 3, this can also be equation 4. So remember, I'm trying to create a system with two more equations, equations 4 and 5, that are down to two variables. So I already have an equation with only two variables in it. So I just need a fifth equation, and I want that fifth equation to have the variables x and z to match equation 4. I need to create that fifth equation using the two equations I haven't touched yet, so 1 and 2. So I'm going to take equations 1 and 2, and which variable should I try to eliminate? See if you can answer that question. Which variable should I try to eliminate right now? There's a correct answer here. Right? And the correct answer is I want to eliminate the y. Why do I want to eliminate the y? Because if you look down at equation 4, there's no y in that equation. And so I want my fifth equation to match. So to get rid of the y, I'm going to multiply this, I'm going to multiply the second equation by 2. So first equation will stay the same. Multiplying the second equation by 2. Okay. So I get 7x minus z equals 5. This is going to become my fifth equation. So now I'm going to just, start the problem kind of over. I recommend just covering this part with your hand or a piece of paper, and now just focus on this new system here and be like, okay, deep breath, I'm just starting fresh. Here's a new system I just have to solve, right? So, you can solve this in a lot of different ways. Substitution method would be great. I like elimination, so I'm going to go for that. This would be 21. Being very careful to watch my arithmetic. So 26x equals 26. So x equals 1. Right, so it's part of my answer. I'm going to take x equals 1, put it back somewhere. So I'm going to put it back right here. I could have also put it into the 5x plus 3z equals 11. Right, so negative z equals negative 2, so z equals 2. So remember x, y, z, alphabetical order. And now I need one more value of y. So I'm going to go back to my original system up here. I can't use that third equation. So either use the first or the second. And I would plug in those numbers to there. So 1 plus 2y minus 3 times 2 equals negative 3. So this becomes 2y minus 5 equals negative 3. So y equals 1. Final answer. In alphabetical order as an ordered triple. Right? So these are what I call funky problems, right? Funky problems, either no solution or all points on the line. Or a funky problem could be where you kind of have this head start, and sometimes that head start can be a little confusing. All right, good luck.